Hi, I'm Dave Nicosia, Warning Coordination Meteorologist with the National Weather Service here in Binghamton, New York. And I'm going to talk to you today a little bit about the polar vortex and what it is and what its role is for this winter. The polar vortex, there's been a lot of misconceptions about it, so here is some clarifications. It's not a new or unusual phenomenon. This is a term we've been using for decades. It's not a surface feature. It's present in the upper levels of the atmosphere. It doesn't necessarily mean it's going to be snowy or below zero temperatures, and not every time it gets cold in the winter is it associated with the polar vortex. It's not really a storm. It's a feature in our atmosphere, and I will explain that. So, going along with what I just said, the polar vortex is always there, even in the summer. Uh, and the main reason for this is it's colder near the polar regions and it's warmer near the tropics. That's because of the tilt of the Earth. So the polar regions get less sunlight than the tropical regions, and the sun angle is a lot lower in the polar regions versus the tropical regions. So on average, it's cold at the polar regions and it's warm in the tropical regions. This is something we all know. Cold air is more dense, it's heavier than warm air. And what happens is when you get these cold air masses, because they're heavier, gravity puts more of the air, pushes more of the air down closer to the Earth's surface. So there's less air at middle altitudes and upper altitudes in the troposphere where the weather occurs. So what happens is you form lower atmospheric pressure at the middle and upper levels of the troposphere. And because in the northern hemisphere, when you get low pressure, you have counterclockwise flow, and it's known as a polar vortex. So I'll talk a little bit more about this detail. So here's a little bit of science behind the polar vortex. So in the cold polar regions, like I said, cold air is much more dense, it's heavier, so more of it is down lower in the atmosphere near the Earth's surface. There's less air up at the middle and upper altitudes of the troposphere, like around 20,000 feet or so. Warm tropical regions, the air is less dense, so the air tends to rise higher in the atmosphere, and you have more air in the warmer tropical regions at 20,000 feet. So, and what is air pressure? Air pressure simply is the weight of the air above you. So if you're at 20,000 feet, for example, you have less air above you. So the pressure is lower. In the tropical regions where the air spreads out vertically at higher altitudes, you have higher pressure. So if you look down, like here's an example of a polar vortex a couple winters ago. Right in this area, the purple and the white, is very low atmospheric pressure at about 20,000 feet up in the atmosphere. So there's very cold air underneath that. And further south in the subtropics and even a little bit along the west coast, the pressure is higher because it's not as cold. So this is an example of a polar vortex that is displaced a little bit further south, and it's over Hudson Bay in this case. But the polar vortex, and the main point of this is it's always there. So in the wintertime, when the sun angles are the lowest and the sun sets in the Arctic, the temperatures get very, very cold. So you, in the purples and the blues here, is where the pressure is the lowest in the middle altitudes. Therefore, you see that's where the coldest air is. And then down along the periphery here near the equator, in this case, looking down on the North Pole, so the equator is towards the edges, it is warm. It's still tropical, so you're still looking at temperatures that are fairly summer-like. And there's a lot more air at 20,000 feet. So you have low pressure over the polar regions, and sometimes, down into Canada and in Siberia here, where the coldest air is, and you have where the red is, where the higher pressure. And in the northern hemisphere, air rotates in a counterclockwise direction, so you have a vortex. So this is in the winter time, but let's look at springtime. Okay, spring, it starts to warm up. The sun angle increases in the northern hemisphere. The sun rises at the North Pole, and you start warming the polar regions, and it starts warming in the tropical regions, or the subtropical regions. So, but you still have colder air near the pole, and again, the warmer air down near the tropics, and again, you have a polar vortex still. And even in the summer, as you can see, it's still colder over the polar regions where there's lots of ice, and even though they have 24 hours of daylight in the polar regions in the summer, the sun angles are still pretty low versus a very direct sun angle in the subtropical region. So you get very warm air, as you see depicted in red. So that's where your higher atmospheric pressure is, but you still have a vortex. And in the fall, it starts to cool off in the polar regions, and again, you can see the tropical regions again are still under higher atmospheric pressure aloft. So this is the polar vortex, and it exists all year round, and it's been existing for ever since we've had the Earth's tilt the way it is. So what happened the last two winters? And they were very cold, and this is when we started hearing about the polar vortex. At least many people have heard the term as it's been widely talked about. The winter of 2013-14, the polar vortex actually shifted southward, and it does that some winters. So you'll see in this case, the polar vortex is a little bit further south than where it normally is, and you can see some of the purple getting into the Great Lakes region and even in New York State. And this is when the Great Lakes had their second highest ice cover since they've been keeping records of ice via satellite. The polar vortex in this case, shows the departure. Where it's purple is where it's further south than normal. And you can see the polar vortex is displaced. And this was one of the coldest winters on record for the Great Lakes region. And then this winter, same thing. The polar vortex shifted further south than what it normally is. And you can see we had a cold winter again last year. So that's what happened the last two winters. So what about this winter, or the lack of winter that we've seen this year? This is what we've seen so far. The month of December, in the blues and especially the purples, that's where the polar vortex has been, and it's been way up north, much further north. As you remember, in the cold winters, the polar vortex was more closer to Hudson Bay, but so far for the month of December, which was a record warm month in the Northeast, you'll see the polar vortex was way to the north. Therefore, it was very mild. And another thing, because of this polar vortex being much further north, the polar jet stream, which is at the boundary of the polar vortex, was much further north. And if we look at the jet stream, you can see in the reds here and the oranges, we had a very strong Pacific jet stream bringing Pacific air into the lower 48. And Pacific air is a lot milder than polar and Arctic air. So we had a very mild month. And the polar jet stream was much, much further north. So far, that's what we've seen this winter. And this week, the first full week of January, we've seen some changes on the horizon. Over the next 2 weeks, the polar vortex actually is projected to shift southward towards Hudson Bay, very similar to what we saw the last couple winters, although it may not be as cold, but certainly a lot colder than what we have seen. So you can see the polar vortex is projected by the middle of the month to shift southward. So that is a big change from what we've seen. And if you look at this, the polar jet stream then at the periphery of the vortex is now coming out of Canada. So instead of our air coming off the Pacific Ocean like I showed you, the air is coming out of Canada, and that's going to make a big difference. So we'll be seeing more Canadian air masses, which means through the middle of the month at least, and possibly beyond, we're going to be in a much more wintry pattern. Now, I'm not saying it's going to be as bad as last winter, but certainly it'll be much more wintry than what we have seen in the past. So, in summary, this week, very cold, especially Monday, today. But by the end of the week, it does relax a little bit, and highs can get up around 40 again. But then next week, the cold air comes back with a vengeance as that polar vortex pushes south, and it looks like it remains cold. And it looks like at least through the middle of January, and there are some indications it may last longer. This cold, wintry weather, but it's too early to tell if it'll be super, super cold like we've seen the last couple winters, or just cold, like more normal cold. Certainly, this is very good news for the winter sports enthusiasts who are, itching to get out on the slopes, or get that snowmobile fired up, or there's ice is starting to form on some of the ponds, lakes. So hopefully, this can help in the winter sports arena. Not so good news for people who don't like winter, but it is upstate New York and it is January. So that's all I have for now. Have a wonderful day.